Hello and welcome to Chapter 9, Section 3 on finding the area of trapezoids. This starts on textbook page 685 and goes through textbook page 688. Now, trapezoids, when you learn about the area, which, just a reminder, the area is the amount of space that's inside the trapezoid. And when you learn about trapezoids, there are going to be several different dimensions that you have to look at. So let's go ahead and get started here under the real world link on textbook page 685. So it says Kiana has a bay window in her room. So the bay window is sort of like that window that kind of juts out from the house, and there's a place for a seat. So it says the window seat is in the shape of a trapezoid. She needs to make, so let's go ahead and underline trapezoid because that's important. That's an important part of the problem. She needs to measure the seat in order to sew a cushion for the seat. The blue trapezoid, which is right there, in the diagram below represents the dimensions of the window seat. Use the diagram below to describe the relationship between trapezoids and rectangles. So let's talk about first the relationship. The number one thing is you need to be able to identify the bases of trapezoids. When you find trapezoids in problems, they won't always be sitting on their base, so to speak. So in order to identify which ones are the bases, you need to look for the parallel lines. Parallel lines are lines that sort of look like that, and they are never going to intersect. So you want to picture them going on forever and ever, and as long as they never intersect, that would be a parallel line. As opposed to, for instance, like that. Those are not parallel lines because those will obviously intersect. So you're looking for, I'm going to go ahead and erase this now, and I would like you to keep it on your paper. So what you're looking for here, the first thing you're looking for is those parallel lines. So you can see right here and right here, those are going to be the two bases. So let's go ahead and count those now. Count the dimensions, or the boxes rather. So when we count boxes, just like we did for triangles, we're going to just put a little tick mark in the middle of the box. So 1, 2, 3, 4, 5. So I'm going to label that with a 5. It doesn't matter which one is base 1 and base 2. Those are interchangeable, and that's because of the commutative property of addition. So now let's check out the other base. We have 1, 2, 3. So the dimension up here for the length of the base is 3. Now what does matter, like I said, is that you are able to identify the correct pieces as bases. So the reason why we know these two are the bases, the 5 and the 3 that we've identified, is because if you look, at an extension, you can tell that those two lines are never going to intersect. So now we've got base 1, we'll say is going to be 3, and base 2, we will say is 5 units. In order to find the height, remember, just like with the triangles, you're looking for that perpendicular angle, so it should make an L. I've identified it here for you, and notice in this particular problem, they haven't identified it for you, so you needed to be able to recognize that that makes a 90-degree angle. So right there is where your height is going to be identified. So we have a height of 1, 2, 3. So we're going to put 3 right there for our height. And actually, let me go ahead and change that to purple, 3, okay? So everything there has to do with the trapezoid. And let me change this back to purple too. I'm going to keep that 90-degree angle pink, but I want everything to do with the trapezoid to be. There we go. Okay, so 1, 2, 3. There we go. So everything to do with the trapezoid is going to be purple. Now for the rectangle lengths, I'm going to change colors here so that we can count them. So for the rectangle, I want you to first notice the height of the rectangle. So 1, 2, 3. So what do you notice? You should have noticed that the height is the same for the rectangle as it is for the trapezoid. So that's one relationship. Then you want to notice that the length, 1, 2, 3, 4, 5, 6, 7, 8. So the length is going to be a total of 8. And what you should have noticed is that when you add the two bases together, base 1, base 2, doesn't really matter which one is which, you get this total length of 8. So hopefully you can start to see where these formulas are going to come from. It says, what is the relationship between the measure of the rectangle and the measure of the trapezoid? All right, so question number 2 says, what's the relationship between the measures of the rectangle and the measures of the trapezoid? So while we were doing that problem, we recognized the following. So we recognized that the sum of the two bases is equal to the length of the rectangle. So you want to make sure that you get that copied. All right, so you want to make sure you get that copied here. It says the sum of the two bases is equal to the length of the rectangle. The height of the trapezoid is equal to the height of the rectangle. So we talked about that while we were counting the dimensions of the trapezoid and the rectangle. The next question says, how is the area of a trapezoid related to the area of a triangle? I'm sorry, of a rectangle. As you can see here, we have a sample answer. It says, since two equal trapezoids make one rectangle, the area of a trapezoid is half the area of the related rectangle. So it has to be the related rectangle. So moving on now to textbook page 686. Even if you don't really understand the concept from the real world link, that's okay. That was just sort of a warm up to get you connected to what we're going to be learning about. So at the top of page 686, you want to see the key concept, which is the area of a trapezoid. All right, this says in words, the area A, notice they're pretty consistent about that area being a capital A, of a trapezoid is 1/2, so 1/2 of the product means to multiply, of the height, and the sum means to add, of the bases 1 and base 2. So as I indicated before, it's not important which one of these is base 1 and base 2. It really is not. They are interchangeable, but what is important is that you can identify that these are the bases and not these guys here. So you need to make sure that you understand that you're looking for the parallel lines. So I'm going to go ahead and erase that. And now we're going to look at the formula. At first glance, the formula can be kind of intimidating. But remember, just like when we were doing 1/2 base times height for the triangle, what this also could be would be area equals height times base 1 plus base 2 divided by 2. Because remember, multiplying by 1/2 is the same as dividing by 2. So as you can see, I went ahead and erased that second formula. I did just want you to understand that even though it looks kind of intimidating, it's very similar to the other formulas that we've been using. A trapezoid has two bases, base 1 and base 2. The height of a trapezoid is the distance between the bases. So what they're saying is this distance is going to be the height. So notice the height would be the same here, here, and actually where it's on a dotted line there. When finding the area of a trapezoid, it is important to follow the order of operations. In the formula, the bases are to be added before multiplying by 1/2 of the height. So you want to make sure that you are going to add the bases before you multiply 1/2 of the height. It says the height is the perpendicular distance between the bases. So perpendicular, remember, that's what you're looking for, that perpendicular box. Sometimes they won't give you the perpendicular box, and you just need to notice that it's the up and down portion. It makes an L, so you can see that there's an L right here. So I'm going to go ahead and erase that now. It says the two bases are parallel. They will always be the same distance apart. And that's what I was talking about earlier in the video when I was saying that these can go on and on and on forever, and they will never ever intersect with one another. Let's look at example 1. It says find the area of the trapezoid. The bases are 5 inches, so let's go ahead and block this out for just a moment. So before we even actually start looking at the trapezoid, since it's an area problem, we're going to start with the formula. Area equals. Now what we're going to be looking at is we're going to fill things in. So since we're finding the area of the trapezoid, you and I are going to pretend like none of this is here. Because all of that right now, don't cross that out. I'm only doing that because I want you to work the problem out with me next to it. So out here to the right, you can see that I have written the formula for area of a, sorry about that, that's my dog playing with his squeaky toy. So right now, we're going to go ahead and fill the things in. We don't know the area, that's what we're solving for, so we're going to leave the capital A right there. Then we know we have to write the 1/2 because that doesn't change. It doesn't matter what our dimensions are, we have the 1/2 there. And now we need to identify the height. So just like we said before, you're going to look for that perpendicular sign right there, that little L looking upside down L. And so we can see that the height in this problem is going to be 7 inches. So let me change colors here. We're going to do that in pink. So it's going to be times 7, because that's the height. Then we're going to go back and put the formula in again. So base 1 plus base 2. So let's see if we can find out what base 1 is. So base 1 we could say is 5 inches. So we're going to put a 5 here. Base 2 we're going to say is 12 inches. So we're going to put a 12 here. And I'm actually going to have to mess up the color coding here a little bit because I want you to be able to see this. So let's see if we can get that. There we go. There's base 2. And now that you've plugged everything in, so remember, there's formula, substitute, solve. So you've done the formula and the substitute, and now comes the solving part. So now what we're going to do is start from the beginning. So we've got A equals 1/2, because remember what that last note just said. Make sure that you add the sum of the two bases first. So 1/2 times 7 times, and 5 plus 12 is going to give us 17. So now we're beginning to see a new problem emerge. So what we're looking at here is now we're just going to need to multiply everything that we have here. So we've got A equals 1/2, and I'm just going to do, I'm going to go ahead and do the 1/2 times the 7. So when you're looking for 1/2 times 7, you want to think about 6. So 1/2 of 6 would be 3, right? So, but it's not just 6 because it's 7, so it's going to be 3.5. If you think about having two 3.5s or 3 1/2s, then that makes 7. So 3.5 times 17. And so now we're going to, now notice this isn't distributive. You're not going to distribute that 1/2 out. This is just 1/2 times 7. So we went ahead and did that. We divided 7 by 2. And now we're going to multiply 3.5 times 17. So as you can see here, I got 595, but you can't forget to do your decimal work, so you want to do one swoop out and one swoop back in. So my final answer is going to be right here, and it's going to be the area of this trapezoid is 59.5, and I need to see what my units were. I look back in the problem over here, I see they were inches. And remember, since it's an area problem and you multiplied several dimensions together, you're going to do squared. So I know there are 3 dimensions here, but really you're working with area, so that's how you're going to say it, 59.5 inches squared. Don't forget that decimal. Make sure to put a box around your answer. Now, as you're working these out, you want to make sure that you are working out all the steps just as I've shown you here. Now you want to take a look on textbook page 687. At the top of 687, you see the example here. It says find the area of the trapezoid. So again, we always start with the formula. I expect that you're writing this as well. And now we need to identify the pieces that we're going to plug in. So since it's asking us to find the area, we know we don't have the area. So we can go ahead and safely write that area equals 1/2. That doesn't change no matter what numbers go there, unless of course they gave you the area and you were solving for missing dimension. So now you have 1/2. Now we need to look for the height. The height in this problem is going to be this 9.8 meters. We know that because we're looking at the perpendicular sign right there, and that's the distance from the top base to the bottom base. So it's going to be 1/2 times 9.8, and then we need base 1 plus base 2. So it's going to be plus base 1 plus base 2. So the first base we have is going to be 7, and the next base that we have will be 12. I keep forgetting that that is not going to work. There we go, 12. And now we need to go ahead and, as the book told us before, you need to make sure that you leave this first part alone. So area equals 1/2 times 9.8 times, and 7 plus 12 gives you 19. So now you can go ahead and multiply that out, and you will get that the area is 93.1, and remember that it's going to be in meters squared, or square meters. Notice on these do these problems now, I have actually already started by writing the formula for you. So you want to make sure that you do the same thing now, and pause the video and go ahead and work through the problem. Welcome back. So hopefully you were able to work through the problem. Notice they're asking you to find the area, so we can safely write A equals 1/2. Now we need to locate the height. And now we're going to look for that height. And again, we're looking for that perpendicular sign right there, so we know that 8 centimeters is the height. So it's going to be times 8. Then we're going to do a our parentheses here. And then it's going to be, and notice I always put both parentheses and the plus sign almost immediately. So now I'm looking for base 1, which I'm going to call 11. So I'll put 11 in there. And base 2, which I am going to call right here, 14. And now we want to work through that math. And for this one, we got lucky. We can actually cross simplify. So let's go ahead and do just that. Okay, you can see we divided out the 2 on the bottom, and dividing oops, sorry about that. Let's take that back. Scratch that. Sorry, we've got area equals 1/2 times 8, and I didn't want to get ahead of myself. 11 plus 14 is going to be 25. So no matter how tempting it is, you want to make sure to get rid of that first. Get that sum added up first. So now you can go ahead and look at cross simplifying. So we can cross simplify the 2 and the 8. 1/2 times 8, you're going to get 1 on the bottom, 4 on the top. And then you will be left with area equals, you have 1 times 4, so that 1 right there times 4 gives you 4 times 25. And then your final piece is going to be area equals 100. And you can't forget, you got to go back and look for that unit. So in this case, it was centimeters. And because it's area, it's going to be centimeters squared. And then put a box around your answer. All right, so welcome back. Now we have the problem here. So let's go ahead and first identify the height. So we're looking for that 90-degree angle, which we see right here. And we see that that is 4. So we're just going to write a 4 there. Times, let's go ahead and get that in there. I immediately put the parentheses in the plus sign so that I remember to do all of it. And then we're going to look for base 1 or base 2. And again, they're interchangeable. So now you've got 4.8 here. All right, so I've got my pen situation here under control now. So the height is going to be 4 meters. We're just going to put the 4 there. And then base 1, we're going to use, and again, base 1 and base 2 are interchangeable. We're going to use 4.8 right here. And then for base 2, we're going to go ahead and use 2.5 right here. So I might have needed to leave a little more room, but that's okay. And let me make that little point a little clearer. Okay, so now remember, because of the order of operations, you want to add the 4.8 and the 2.5 first. So I'm just going to do that over here off to the side. So 4.8, 2.5. And as you can see, we get 7.3. So let's go ahead and plug that back in here to our formula. So we have A equals 1/2 times 4 times 7.3. Okay? So now we're going to go ahead and just use the order of operations from left to right. So we're going to cross simplify this 2 and 4. We get 1 here and 2 here because we're dividing out 2. So on the top, it'll be 2 times 1 is 2, and then on the bottom it'll be 1. So you could even rewrite again if you wanted to, and you would have 2 times 7 times 3. And that'll be your final step. You'll do the work over here off to the side. All right, so now you are looking at the final problem. If you'll notice, we did area equals 14.6 meters squared because we were finding the area, so you want to make sure that that is in square meters. For C, you have a trapezoid here that's flipped upside down, so we're going to go ahead and work from that problem just as it is. So hold on one second. So since we're solving for the area, we go ahead and write A here. Now remember, if it's a missing dimension problem, you're not going to start by writing A again. You're going to have the formula, which you always start with, but then you're going to go ahead and plug in whatever they gave you. So, but for this one, we are solving for area. So it's going to be area equals 1/2 times. Now we're going to have to look for the height. Again, we're going to look for that perpendicular box. See it right there? I just drew over it in green. So it's 0.3. So I'm going to write 0.3 here. And then in parentheses, let's go ahead and get that color back here. It's going to be base 1 plus base 2. So let's find those bases. So we can use base 1 up here, which is 1 foot. And we can use base 2 down here, which is 0.5 feet. Okay. So now that we've plugged everything in, we can go ahead and start to work through that problem. As you can see on this line, we have area equals 1/2 times 0.3 times 1.5. Remember, I prefer that you only do one operation per line, so you can tell that we added the 1 and the 0.5 there. So now we can go ahead and start multiplying straight across. I would probably multiply the 0.3 and the 1.5 right away. And you can do that since it's all multiplication. It doesn't matter which order you're multiplying them in now. As you can tell over here on the left, you just want to make sure that when you're putting the decimal back in, after you get that 45 there, you want to make sure you count 2 spaces out because you have 1 to the 5 and 1 to the 3. So then it's going to be 2 spaces in. So that's going to be 0.45 that you got right there. So let's go ahead and put that in our problem. Area equals 1/2 times 0.45. And then we can work that out. Remember, 1/2 is the same as 0.5. So let's go ahead and do that. It's actually probably best if we work straight across in this problem. So I'm going to go on to the next screen briefly so that we can work from here. So we have A equals 1/2 times 0.45. So on this screen, you see the rest of the problem worked out. I'm going to go to the next screen one more time so that we can actually work it out with the 1/2 times 0.3, because I want you to see that as well. So 1/2 again is 0.5, and 0.5 times 0.3. Well, obviously that'll give you 15 here, 1 space out, 2 spaces out, so 2 spaces. So now we have that the area is equal to 0.15 times the 1.5. So let's do that off to the side. And as you can see here, when we do the multiplication, we get the same answer that we got on the previous screen, which is A equals 0.225, and that was in square feet. Feet squared. So remember, you could also have written square feet, which is fine. All right, so this is a missing height problem. So we've got the light bulb here. I wanted to show you the formula. So they gave you a related formula. They said that the height is going to be equal to 2 times the area divided by base 1 and base 2. So what I've done here is off to the left, you can see that I have the original formula right here that I'm going to point at in yellow. So that's the original formula that we've been working with when we have the other known factors, the height and the bases. And now what they're saying is if you're missing the height, if you need to solve for height, then it's going to be 2a divided by b1 plus b2. So this is where it's important that you kept that a as a capital A, because that's the area of the entire trapezoid. So now I wanted to show you that I wanted you to just note that over here, 1/2 times height that we have right here where I pointed to in yellow, isn't that the same as dividing by 2? Just like we did with the triangles. When it was 1/2 base times height, we could have also done base times height divided by 2. So with the triangles, it was 1/2 base times height, or it was base times height divided by 2. So that's what basically this is that I'm showing you right here. It's the same thing. Now I wanted you to understand where they derived this formula from. So now, if we're trying to solve for h, then we can multiply each side by 2. That's where you get the 2a from. So it's kind of a tricky formula, but I just wanted you to know that it's just rearranging the letters. So what they're having you do, though, is use this formula right here that I'm outlining in green when you're finding the missing height. So let's go ahead and get started. All right, so it says missing height. Use the related formula h equals 2a to find the height of a trapezoid. The trapezoid has an area of 108 square feet. Find the height. So the first thing we're going to do is start with the formula again. But the formula we're going to start with this time is the related formula that they just gave us. That formula is going to be h equals 2 capital A, very important that that's capital, divided by b1 plus b2. So let's go ahead and see if we can work from that. We don't know what the height is, and we're solving for the height, so that's why we're going to leave the h right here, equals, then we're going to have part of the formula is 2, so that came from up there in the formula. They gave us the total area. This is A right here, that 108. So it's going to be 2 times 108. That looks like a dot. Okay. And then it's going to be divided by, because that came from the formula above, base 1 plus base 2. So you can see that they've given you the bases here and here. So we're going to just go ahead and add those, or plug those in rather. We're not adding yet. So base 1 will be 12, and then we have plus 15. And remember, that came from right here and right here. And we're solving for this missing height right there. So now let's see what we have here. Let's see if we can work this problem out. First, let's go ahead and do the, I actually almost made a mistake. So first we're going to do the multiplication up top, which is 2 times 108. So we're just going to do that off to the side here. Make sure that it's not directly under your work. So you get 16, 2 times 0 is 0, plus 1 is 1. Oops. And then 2 times 1 is 2. So you get a total of 216 there. So now let's plug that back in. H equals 216 divided by, and then again, I'm just going to have this 12 plus 15 here because I like for you to only process one thing per step. So I think that makes it easier to find your errors. So H equals 216 divided by, and now 27 is going to be on the bottom. And I'm going to go on to the next page so that we can have a little bit more room to finish solving. Okay, so off to the side, when I go ahead and set that division problem up, 216 divided by 27, I realize that it doesn't really help me because I can't get 27 into 2, I can't get 27 into 21, so here I am again at 216 divided by 27. So I just wanted to give you a tip on how to divide that out, or I'm sorry, how to best guess at what you multiply by. So when you look at 27, you want to think about it as being 30. Okay, so think about it as 30, and then think about 216 as being somewhere around 200. So now you're really looking at 3 and 20. Well, I can multiply 3 times 6 and I get 18. I can multiply 3 times 7 and I get 21. And I can multiply, well, hold on. Sorry about that. So 27 times 6 is going to be my first guess because 30 times 6 would be 180. And actually, it's not going to be my first guess because that's way less than what I need. So now I'm going to think, okay, there's a 6 at the end. So 7 times what is going to have a 6 at the end? Well, that's 8. So now let's try 27 times 8. So you get 56 here. 8 times 2 is 16, plus 5 is going to give you 21. And you guessed correctly. So now you find out that the height is equal to 8. Then we need to go back a screen so that we can see what the units of measurement are, and it's feet. So let's go back here. Sorry, it's just going to be 8 feet. Now notice when you're working with missing dimension and you're trying to find the missing dimension, there is no squared at the end of this. This is just the height. So the only time you have that missing dimension, or the only time you have that squared, is when you're finding the area of a problem. Go ahead and pause the video here. You want to start with the formula, and then you can go ahead and work through the problem. Okay, and so we're going to substitute 24 for A because they gave that in our piece of information over there, divided by B1 and B2. They gave us over here was 4, and that's going to be 4 plus, again, going directly from the formula. B2 is going to be 12, and then we're going to work from there. Now, of course, the first thing we're going to do is multiply and divide, so we have some multiplication up here up top. So for 2 times 24, you get 48 right here. And then you want to do your addition and subtraction, or I'm sorry, the addition. I know on the previous slide I said go ahead and do those in 2 separate steps. It's totally okay if you want to do both of them in one step. That way you're not going a mile down your page. So for 48 divided by 16, I believe you're going to get 3, but off to the side I'll do the math. 16 times 3. And yep, you get 48. So H is going to be equal to 3. And it will be 3 centimeters. Again, not centimeters squared, just H is equal to 3 centimeters. How did you do? All right, so again here for example E, we're going to start with our formula, the formula for height. It's the related formula, so it's going to be H equals 2A divided by B1 plus B2. So now we're going to go ahead and start plugging stuff in. We don't know the height, so we're going to leave that as H. 2A, so we're going to have the 2 here, and we're going to multiply times the area, which they told us was 21. Then we're going to divide all of that by 2 plus 5, because we got that from here. 2 plus 5, okay? Now we're going to make sure that we do our multiplication on top first. So we've got H equals 21 times 2 is going to give us 42, divided by, and 2 plus 5 is going to give us 7. So you can see our problem's shaping up now. We've got H is equal to, and of course we know that 7 times 6 is going to be 42. So the height is going to be 6 yards. So again, you want to make sure that you have yards. The unit of measurement is important, and make sure that you don't accidentally put a square on that. On this screen, you can see the be precise by checking your answer using the formula for area of a trapezoid. So I'm going to use the last problem to show you how to check your answer. So now, if you remember, the formula for area of a trapezoid is going to be A equals, and actually let's go ahead and put that in purple. It's going to be A equals 1/2 height times base 1 plus base 2. So now we're just going to plug everything in and see if it all works. So they said that the area was 21, so we'll put that there. 1/2 times the height we just found out was 6, multiplied by B1 plus B2, which is going to be 2 plus 5. So now we're going to work that out. 21 equals 1/2 times 6 times 7. And let me shape that 6 up a little bit. All right, and then we have that 21 is equal to 1/2 of 6 gives us 3 times 7, because that 7 was right there still. And then our last piece, 21, is equal to 21. So that is how we know that our answer is correct. So if it asks you to check your problem, you want to check the height by putting it back into the original area formula. Now you're looking on textbook page 688. So on textbook page 688, it says, first we'll read this over here on the side. It says mental math, to multiply 1/2 times 51 times 64, it's easier to use the commutative property to reorder the factors as 1/2 times 64 times 51, and then take half of 64 instead of half of 51. So they're just trying to help you with your mental math skills here as well. So let's go ahead and put that back in. All right, it says the shape of Osceola County, Florida resembles a trapezoid. Find the approximate area of this county. So as you can tell right here, they have started with the formula. And I would like you to go ahead and actually, I'm not going to have you work this one out. We're just going to kind of look at the steps that they did. So they've started with the formula area equals 1/2 times base 1 plus base 2. And I would like you to go ahead and identify the pieces though. So this right here is going to be your height. And you know that because of this perpendicular angle right here. I'm going to do that in pink. So see that perpendicular angle? That's how you know that this line is your height. So if that line is your height, then you can find out that this is your base and this is your base. So you can see that they've plugged in 48 and 16. Hold on one second. Yep, 48 and 16 right there. And then they've got 64. And then if you take 1/2 of 64, you get 32. And then it's 32 times 51. So you get the answer of 1,632. Now I want you to notice at the bottom here that they did say 1,632 square miles. All right, miles squared. Now make sure when you're doing miles that it's MI, not M, because M is for meters. All right, and now lastly, we're going to go ahead and look at your homework. I would like you to work on numbers 1 through 5, please. And actually, you know what? I'm going to amend that. I would like for you to just work on numbers 1 through 4. So if you could come to class with numbers 1 through 4 done, that would be snazzy and wonderful. And see you in class. That's me, Ms. Rickfelder, and good luck. Thanks for listening.